What is the most used man-made material on Earth? You guessed right, it's concrete. Look around. It's everywhere. Sidewalks, driveways, foundations, floors you stand on, and even entire buildings are made out of concrete. So why don't we discuss it more? In each episode of Concrete Logic, we will explore one concrete-related topic with the help from industry professionals that are shaping the future of the trade. We'll talk with suppliers, contractors, architects, engineers, specialists, and even some proponents of competing materials about their views of concrete and their vision of its future. And welcome to another episode of the Concrete Logic podcast. And today I have Keith Robinson with me. Keith, can you tell us a little bit about yourself?
Sure. I'm a specifications writer, one of the few actual specifications writers compared to the thousands of people that edit specs for all those. I pity the pool of concrete finishers that have to read the documents because sometimes the documents aren't as well informed as they should be. But yeah, I've been writing spec for 40 years. I create master documents. I write for large clients and basically look after an entire specification team at the architectural company I work for.
Yeah. And I think you might be the first Canadian I've had on the podcast.
Well, we're a rare breed.
Yeah. No, we've had some people that are close to Canada. I tease my wife; she's from Michigan, or that's like little Canada, because I used to go up to Windsor, Canada. I'm on this side of the country. I know you're on the other side, but I always thought Michigan was kind of part of Canada, especially the way they talk. So
yeah, we do too.
Yeah,
we like guys from Michigan.
Anyhow, yeah. So Keith, thank you for coming on. I guess my timing or your timing couldn't have been better because the last podcast we released was about flooring adhesive. And you sent me a white paper that you wrote that is about floor finishing for concrete as far as flatness. So I was like, oh man, this is uncanny timing. Or Keith knew when to reach out to me. But so could you tell us a little bit about this white paper, and then I'll ask some questions as you go along?
Sure. I do work for a number of trade associations in Canada to try and align their work practice with specifications. And for several years now, I've been working with the National Floor Covering Association of Canada. They've had issues with floor flatness literally for decades, trying to establish responsibilities for the concrete trade, responsibilities for repair and finishing and preparation of floor surfaces ready for installation of resilient floor coverings, carpets, hardwood, you name it. And it seemed like it was always a battleground. Nobody accounts for a portion of the work that's actually required to create a suitable, I'll call it planarity, like that aspect of flatness that doesn't depend on whether the floor is sloped or whatever. It's the actual gross surface profile of the floor. And we have standards that the concrete finishers use, ASTM E1155 for the dip meter kind of measurements. That's perfect. And that's absolutely ideal for looking for the structural tolerances. But it has limitations so far as the application of floor finishes is concerned, because it's measured only on certain lines, either and along a certain length. It doesn't measure to within the perimeter. It doesn't measure across joints. There's a lot of issues for the floor covering person that doesn't address corrections that need to be made in order to have flatness that will actually accept materials.
Yeah. And what's the dip meter? Can you explain that to our listeners?
Oh, the dip meter. Yeah. It was an instrument that was invented by, I'm going to get it wrong, Face Consultants. It's a really cool machine. Basically, you run it across the floor, tiptoeing it back and forth across along either a 45-degree section across a floor area between structural components. And what it does is it looks at all the waves and surface topography.
Yeah, that's
created by the finishers. They put their trowel across, and if you've got a power trowel, if you're one direction, we end up with troughs and furrows. If they go 90 degrees, if the concrete is not set up in time, you tend to get, I call them moguls, like on a ski hill. Sometimes, very rarely, we get the opportunity to go 45 degrees back across that and get really good floors. But so much of it is the quality of that flatness is all about the concrete going into the project and what the cure time is.
Yeah.
Or the setup time.
Yeah. So, yeah, there's always there always is conflict with figuring out what the floor flatness is, because some concrete guys like ourselves, we do that meter, the floor flatness, we do that work before the third party comes, and we turn that over to our client ahead of time and say, hey, this is what we come up with, because we're uneasy when it comes to a third party guy and who they send out as far as doing the measurement as well. So we try to be in front of it that way. And it only works if you're being honest with it. So I'm sure what you've seen is there's ways to you can take different lines on that floor and have fantastic results. And then you can go to another part of that floor and have terrible results, meaning that you're not meeting the floor flatness that is required in the specifications.
Yeah, and that's allowed in the test methodology. You're allowed up to 70% deviation. And that's the difference between having a hole in the floor or a mountain in the middle of the floor.
Yeah. But as a concrete guy, our concern is staying away from the conduits that come out of the floor, the columns and things like that, because when you're trying to finish around those things, it's more difficult. It takes more effort to do that. And so I think that's the reason why sometimes you take advantage of those ways that you can take those measurements to stay away from those things.
And I think it's all fair. And I think when you're working with, face it, concrete is liquid stone. It's going to do what it wants to do. And you're trying to get it as close to a reasonable finish as you can. You got to spend some time with it. If you don't spend the time, then you get a really horrible job. Or you spend a bit more time and you get an all right job. Let's not take away the skill level of good concrete finishers, because it's hard work. I did that for one summer. I know what it's like pushing around concrete. It's hard, heavy work. And that's standard. As you said, you can run it at 90 degrees to the floor. You can run it 45 degrees across the floor. It's not like in the old days with the old style straight edge measurement set up on a level and randomly placing it somewhere on the floor. You could really cheat that test. But I think the current E1155 gives a really good indicator of what the floor condition is along those lines of measurement. And so that's what we're talking about, along the lines of measurement. It doesn't really give you an idea of what the floor is like all over. And I think that's appropriate. Again, the measurement is made within 3 days of concrete placement. Concrete, as it sets up, it's absorbing water, you've got sun shining on it. If there's not proper shading, if you've got a low water mix, it starts to curl. You start to get the edges pulling up. And of course, as it curls, it also wrinkles up in the middle like a shrinking apple kind of thing. There's a lot of things that happen with concrete after 3 days as well. The curing regime that's set up by either the concrete finisher or the general contractor. Up here in Canada, it's usually the general contractor looks after the curing.
Oh, wow.
And we're dealing with freezing conditions and horrible things for concrete. But
So what do you normally see up there? That's different from down here as far as the general contractor curing the concrete. What do they normally cure?
What they're going to do is they're going to go for the highest, earliest strength gain concrete mix they can find. They're going to try to attempt to wet cure it for maybe 2 days if we're lucky. They'll try to keep it covered for as long as possible, but you got to keep the building moving. There's a lot of things for weather that really don't help that surface condition of concrete as the building ages. And of course, temporary heat. It's a whole lot cheaper not to heat a construction site than it is to put up plastic sheets and try to heat not just that enclosed area, but because those sheets, they leak like crazy, all the rest of the outdoors as well. So also not very sustainable. So there's a lot of things that happen to concrete, and that's what the National Floor Covering Association was trying to address, that there's more to flatness than just that I'll call it the wet finishing. You're dealing with plastic concrete and pushing it around. And by the time then the floor covering installer comes on site, could be 6 months, 8 months. That slab could have been cold for 5 or 6 months, which of course traps any moisture in the slab. So then all of a sudden you throw heat on the slab and you get this, all the moisture that gets driven out of the slab. The slab is cold. You get condensation on the surface. It's just horrible. And I don't know what you're talking about. It's 28 days. Concrete strength is fine. But we tend to ignore the fact that, there's other factors that affect the quality of that concrete slab. All of which actually changes over time. It probably settles down after about 9 months to a year, the most amount of change on the surface of that slab. So you can actually lose up to 50% of that flatness and levelness that the concrete finisher worked so hard to achieve. So on the day that you measure it, you could get say we got a really flat floor using conventional methods. You got FF30. That's an amazing floor, and that'll probably do for almost anything you want to apply to it. But after 6 months of those kind of curing conditions, you might be lucky to have an FF15, which I think my wife is just waving me goodbye.
No worries.
No worries. At FF15, I don't think there's a concrete finisher alive that would accept that as representative of their work. And it's not what they work so hard to achieve.
No.
So there's always this differential coming up, and we have clients that I work for that say, I want dead flat floors. I've got a hospital operating room. I've got laboratories. I've got a high stack warehouse. You've got to specify FF50, FF100. And I'm like, oh, crikey, how are we going to get that and maintain that? And I think most specifiers, they don't understand what it takes. So and I'll say we're a guilty party to all of this, because we'll just say, oh yeah, we want a super flat floor. Let's put in a requirement for FF50, sounding like we know what we're talking about. No, it just doesn't work that way, because of course, the higher you get on your FF, the greater that percentage change is going to be over the months. So by the time you get to FF100, which is special concrete mix, special equipment for placing, special finishing, long-term curing, permanent heat on top of that concrete slab, you name it. It still results in upwards of 70% of that flatness being retained after 6 to 9 months. Which is why, of course, I have a lot of people putting I want to put in that shrinkage compensating admixture. Yeah. So that only delays the problem. It doesn't actually solve the problem.
Yeah.
If you don't look after all the rest of the stuff. So we figured out that there's something else that needs to be done, because currently what happens is that flooring installer is being made responsible to prepare, because it's floor preparation, to fix all of this new topography that happens on the floor, that happened after the concrete was actually accepted that 3-day measurement mark. Well, flooring installers don't have the equipment. It hasn't been included in the price. They're being made to pay for stuff that they have no control over, right? GC has control over the condition of the floor up from the time that the concrete finisher leaves the site up until the time that the flooring installer comes on site. A lot of things can happen to the slab, and how do you account for that in the specification? How do you account for that in the construction budget? How do you account for that in your bid? It's an issue. It was a huge issue.
Yeah. Yeah. So how do we solve that? I don't even know the answer.
I'll tell you, in Canada, we have something called the Red Seal Contractors Program. It's a form of standardized apprenticeship for different trades. And there's a Red Seal program for concrete finishers. It talks about all the things that concrete finishers can do, from placing and leveling and curing of concrete, the repair and remediation of concrete surfaces after placement, right? They also look after application of resinous coatings and self-leveling toppings and all sorts of other things. It's all built into that particular trade definition. And I was talking to some representatives from Concrete Canada. They're one of the associations that represents floor finishers. They said, Keith, you're missing something entirely. You got all that wet finishing well looked after. You understand that's good for you, but you're missing a component of the trade. It's never specified. And when the GC goes out and says, okay, we got to fix the floor, they all get called. They go in and they've got grinders. They've got patch and repair materials. They go in and they basically say, we call it dry finishing. So they'll go in with the grinders and they'll do like a skip grind across the floor. Yeah. Knock off all the high points. And it might be only a 1/16 or an 1/8 of an inch, 1.5, maybe 2, 3 millimeters, which doesn't affect the structural quality of the slab. And then if there's any drastically low areas, they'll just use a wide trowel and screed it between 2 high points to flatten everything out. And it's like, wow, how do I specify that? And they said, good thing to do is to start off with a cash allowance. And I went, that's brilliant. I remember reading in the American Concrete Institute, they actually say about coordinating tolerances between all that Division 3 concrete work in all those Division 9 flooring works. And they said, Mr. Engineer or Mr. Architect, you really should include a cash allowance to correct those floor surfaces.
Yeah.
And it's like, oh, wow, it's been in front of my face for 20 years. There's a standard that affects the installation of resilient sheet floors, ASTM F710, about surface preparation that says, oh yeah, you might have to mechanically prepare those floor surfaces to bring it into a flatness acceptable to the application of floor finishes. That's been, and by the way, Dean Kraft, one of your previous speakers, he sits on that committee, and I'm talking to him, and he says, oh my God, Keith, I think we've got it all wrong in the standard. He says, that's brilliant. So what do you propose? I said, first off, we've got to bring back a straight edge measurement, because a straight edge is the only thing that really can pick up those surface deviations necessary to prevent material runoff. Like when you're trying to place rigid square materials on a floor and you've got a hump in the middle of the floor, well, you can't cut and trim all those tiles to make it fit around those lumps and humps. You just create a bigger problem than what you started with. So there's this, all of a sudden, it's like it was implied in the standard, and then it's like nobody followed up on it. It's, oh my gosh, there's your solution. And the best way to measure that is a randomly placed straight edge. If you can imagine taking a straight edge and pushing it around the floor in front of you, basically, and when you find a high point, the straight edge goes up, it comes back down again. You can actually measure those high point areas. You can find the same thing with more technical tools like laser scanners, and some guys use string lines and plumb bobs to lay out a grid across the floor. But however it's done, you can get a really good representation of how much that floor surface has changed over time. Cash allowance is appropriate because you only have to spend as much as needed or more, because if the concrete wasn't good to start with, then you've got more that you have to expend from your cash allowance to prepare that floor. But it comes down to this missing trade scope.
Yeah.
So easy to repair, so easy to address, and we've missed it. And yet there's skilled workers out there that do that for a living all the time.
Yeah. There's actually, and I'm sure some people are listening to this and they're like, there's no way there's people out there that are putting aside an allowance to fix floor flatness. But there is a large retailer, I don't want to say their name, but large retailer out there that builds big warehouses, and they actually do that. And that was my first time that I was on a project that had that allowance, and they had that trade, that middle ground. They had them planned in the schedule, which I personally thought was shocking. I was like, oh, you're planning on us not providing what you need. But the floor flatness, they do have an allowance, but they still expect a high quality finish. So they have an allowance, and then our client, they were sharing with us that they were one of the GCs that used the allowance the least across the country. So they wanted to make sure we delivered a high quality product, even though they did have this allowance to do the grinding of the floor. They wanted to make sure we'd still delivered a high quality product, and so they wouldn't have to use that allowance as much.
Yeah, and I've written conditions that talk to that as well. It basically says this is not meant to repair work. This is not to say that, oh yeah, we're going to be fixing the floor after the fact anyway, so we'll just slop the concrete down and do what we can do. We don't have to spend the time. No, you need a good quality floor to start with. I'll say minimum FF25, better yet FF30. So we're still pushing that, what's reasonably expected from using standard tools and materials. I should also say American Society of Concrete Contractors also had a position paper.
Yeah.
Yeah. That says,
we have all kinds of position papers. I think there's 36 of them. I like them.
I like them too. They're great. It's every time I have a problem with concrete, let's see what ASCC says. Their position paper number 6, so it was an early one, says, hey, you should be doing something about this and coordinating between Division 3 and Division 9. And oh, by the way, the way you guys measure things in Division 9 is different than the way we measure in Division 3. So you need to, basically the position paper said, flooring installers need to be recognized for their tolerances. They're different. They're a lot tighter. They are equivalent to FF50 to FF100 many times. But again, that goes back to this new position paper, best practice for straight edge measurement. It sets up the responsibility to the general contractor to turn over an appropriate floor for the floor covering installers. It recognizes the good work that the concrete finishers did. It brings in an otherwise unrecognized portion of the construction finishing trade that is always brought in to repair floors at huge expense, because it's usually an extra to the project that the owner doesn't want to pay for, because they expect that perfection, that level of FF50 or FF35 that they're not getting, and they're pointing fingers. Everybody's pointing fingers at everybody else. The concrete finisher, I did my job. The floor covering guy saying it's not my responsibility. GC going, I don't know what happened here because you didn't control the conditions. And everybody not really understanding what the concrete is. It's a beast. It has a mind of its own, and it will do what it will do. You can place concrete one day, it'll behave perfectly. The next day, it's a wet, cloudy, overcast day. The guy on the end of the mix truck, he forgets, yesterday we added in a lot of water because we had a lot of evaporation. Today, he forgets not to put in so much water because he did the same things he did yesterday. Now we have a permanently wet slab. There are issues all over the place. The trades, they're unaware, I would say, of all of the physics that goes into making concrete. And there's no expectation that they should understand the physics, but we can certainly address those outcomes within the project documents and make sure that the owner pays a fair price for the work. We have to get the owners to agree to, of course, the cash allowance in the first place. Large clients, yeah, like your warehouse example, without saying a name, we do a lot of warehouse work for a particularly large retail outlet that pretty much dominates everywhere in the world. And yeah, they recognize that need for surface correction. They also recognize the need for good work at the outset. It works well when you have communication between all the trades.
Yeah.
That's the thing too. Have Division 3 talk to Division 9. Division 9 says, this is what we need. And Division 3 will say, oh, if that's what you need, here's what we can do for you. Rather than, don't blame me, man. I was good on my day.
Yeah. No, it definitely starts with the owner, and then it has to trickle down all the way down, owners, reps, and design team. Everybody's got to be on the same page. That's that one project I was talking about. That was probably the best pre-pour meeting I've ever attended. It was after being in the industry 2 decades plus. That was the one I actually felt was worth my time.
Well, the fact you even had a pre-pour meeting, right? Yeah.
But I felt everybody was engaged, and it started with the owner's rep. He drove that meeting, versus typically we, as a concrete contractor, we're the one that initiates the meeting. We're the one that drives the meeting. We're the ones that provides meeting minutes, the agenda, everything. And everyone just follows along, and I don't feel like everyone's engaged. But when it came from the owner's rep, everybody was paying attention. It was like, this is what I expect. This is what y'all are going to do. This is how it's all going to happen. And so everyone knew that participated in that meeting knew what we all had to deliver.
Yeah.
So I'm sorry, go ahead. And then we'll jump to the straight edge thing, because you said you were getting some pushback on that.
Oh, yeah. And I'll just say that's one thing the National Floor Covering Association recognized when we were working on harmonizing how self-levelers were installed, where they came in and who was responsible. The big realization was the coordination wasn't happening. So they actually wrote for specifications a coordination section that actually does exactly what you just described, brings the concrete people, all of the people, the formwork people, the concrete mix company, the reinforcing steel guys, the finishers, anybody that has to put conduit or anything else in the floor or piping, brings them all together for that first meeting and gets everybody to agree and talk about what they're going to do in the future. But yeah, and if any of the listeners want to see that document, I'll send you a link. It's a really good document, and it solves a lot of those coordination issues.
Yeah, no, that'd be good. So the straight edge, a couple things. Let's talk about when you're specifying for a job that would require this coordination between the flooring and the concrete contractor. What's your curing expectation? What do you specify in there? What's best practice?
Yeah, I have a really large curing specification to start with. It's 8 or 9 pages long. It sounds
It's
like
not just spray chemical cure on it.
it's not just a chemical cure on it. No, that's the last thing. Although if it's a part of a plan, we'll look at it. But you can't beat wet curing. Let's face it. You can't beat temperature control of that slab. If you allow that slab to cool off to below freezing, even though it's attained its strength, you still have a lot of free water within the slab, and it tends to expand as it goes below freezing point. And by the time you reach 0 degrees Fahrenheit, minus 18 in my world, ice starts to expand. It does very bad things to concrete, which just upsets everything. So yeah, the curing plan has to be detailed. Most consultants, most engineers don't really understand the curing aspect. Once they have strength, that's good. And structurally, that's fine. But it doesn't recognize any of the work that has to be done later for finishing.
So is it wet cure 7? So I've seen 7 days, 14 days. What? 7 days?
Yeah. So wet cure is 7 days instead of 3. Check moisture emissions from the concrete. Mm-hmm. There are standards for that. They're oftentimes used for flooring. It's a whole different topic. It's about wetness of floors and everything else and appropriate measurements. There are a lot of really good standards for checking that how the concrete is actually releasing all of that mixed water during progress of the cure period, which can be 3 to 4 months. It's more than the 28-day strength gain that most of us are dealing with. When it gets cold, say at freezing point, just above freezing point, say 40 degrees Fahrenheit, 5 degrees-ish Celsius, concrete just stops doing what it does naturally. Any strength gain, residual strength gain ends until it warms up again. So there's a lot of things. So keeping covers on concrete, getting as much temporary heat as possible, ways to retain heat on the concrete, keeping weather off the concrete, keep the snow and the ice and the rain off your concrete, because that delays all of these things. There's so many things that affect concrete, and having a good concrete cure plan. I'm not expecting the concrete to be protected from day one till the very end. But if we can at least extend that protection after the 7-day wet cure to 14 days, maybe 21 days of protection, concrete has had a chance to actually mature. And as it matures, there's less risk of all these other downstream effects on the concrete slab. Yeah. So as I say, most engineers, architects, they'll just refer to some concrete standard, cure in accordance with blah, blah, blah. The contractor says, I've got a top out party I want to get to, 3-day floor slab pour, get on with it, finish fast. And fast is, of course, the biggest thing that destroys concrete quality. So,
yeah. Usually it's pushed by the client's schedule too. So trying to meet that or exceed that. And then when do you do measurement, floor measurement?
We start measurements, and the GC should be measuring the progress of how the floor is changing once they have access to the floor. So you have that initial 3-day measurement from the concrete trade. Maybe they measure the floor 2 months, 3 months after, see how much it is changing. The rate of change can dictate we got a problem or we don't got a problem. And of course, the next point of check would be, at least a month before you're expecting your concrete installer to go on site, or your floor covering installer to go on site, because if there are any preparation methods required to correct that slab to a condition that the floor installer will accept, it's got to be done, and all the curing, all those materials that you apply to that slab have to be cured as well before the flooring material goes on. So a month before, 2 months before, we're either good to go, A-OK, or, oh heck, I guess we're going to have to dip into that cash allowance to make things happen.
Yeah. Have you seen any of the internal curing products out there? Has that succeeded in lieu of the wet curing?
I've had one project where we used an internal cured concrete mix design. It was for a large industrial slab in a manufacturing facility. It was amazing. Oh my God.
Yeah.
Yeah,
Yeah.
it was like, it was the magic cure. Yeah, so internal concrete cure, it addresses a lot of those issues. Again, if you have issues with not maintaining temperature and protection after the fact, internal curing can have just as many problems.
That's what I was going to.
More money for it, but the fact that the internal curing has its own moisture source.
I got you. So it can take the place of wet cure, but we still need to take care of the ambient air around the concrete, is what you're saying.
Correct. Yeah,
I got you. Huh. And then you're measuring the measurement. I know the white paper that you sent me, you said that people weren't excited about it because you were talking about the straight edge and everything. But you mentioned too, you were okay with the 3D scanning, which we utilize. And we actually, that project I was talking about before was the first time we used it. And it shows everything. You got to be prepared to see everything.
It's different.
Sometimes it's overwhelming for clients to see everything. They don't know what to do with it. But like you're saying, the remediation guys that come in before the flooring guy or whatever is being done afterwards, at least in my experience, they utilize that data. They knew where the high spots, low spots were, and everything like that.
Yeah, it's kind of like a cut and fill exercise at that point.
Yeah.
And again, if the concrete is being put down with care and attention, we're usually talking a couple of millimeters of correction. It's not a big deal. And it's not pointing fingers at anybody. It's just work that's necessary to be done. Always has been. We've just missed it, which is why people get upset. And that goes back to the straight edge, because a lot of concrete finishers, they fought long and hard to get recognition of the new now, which is now 25, 30 years old, ASTM E1155, or the other one for the surface waviness index, FFFL and surface waviness, same machine, same little bot measures both. And of course, they don't want to go back to a straight edge measurement. Of course, everybody thinks it is that old fashioned straight edge measurement, which really was designed to show the floor to its best advantage. It really was the pig's ear silk purse kind of comparison. You take the measurement in one place, in this one place, and it looks beautiful. Everywhere else it can look like the Sahara Desert full of sand dunes. Doesn't matter, so long as it's perfect in that one location that you place the measurement stick. That's not what we're advocating here. And so one of the things I'm trying to encourage concrete finishers to do before they say we don't want no straight edge, and that's the words we hear, is read the new procedure. It's best practice. It really does mimic exactly what the 3D laser scanner provides. It just does it with really basic tools. So you can do it. You don't want to be on your hands and knees with a 10-foot straight edge in front of you covering, the 100,000 square foot warehouse. Yeah. Lasers are really good for that. You have a smaller area, a couple thousand square feet. The straight edge is really practical, really easy to use. Finds all the same dips and hills. Take a piece of chalk, you can just draw where those high points are, and then the dry finisher, if that's what I've been calling the concrete dry finisher, goes in with the grinding machines, skip bumps everything off, planes the surface, whatever term you want to use, and it's very easy to convert not bad floor into a almost perfect floor that's ideal for the floor covering people. They apply their own skim coats and things like that to do what they need to do to enhance their surface bond, and everybody goes home happy.
Yeah.
That's the thing about it is, once you recognize the missing component of work, it's slap yourself on the forehead. I'm getting a very flat forehead these days, by the way. All the time, hit myself on the forehead. It's crazy. It just made it so obvious what needed to be done, and it's one of those things where cooperation between Division 3, Division 9 has come up with a solution that addresses all of the problems. We'll find some new problems, no doubt, but it addresses the common problems that we're currently encountering and stops making people scapegoats for the quality that everybody expects.
Yeah. No, I think that's a good summary of what we're talking today. So I think it's a good spot for us to end today, Keith. If folks want to reach out to you, what's the best way?
Best way is the company I work for is Dialog. It's a architectural engineering urban planning company in Canada. My email address is krobinson@dialogdesign.ca, and I'll send you that link so you can include that on the bio.
Yeah.
on your website. And I'll also send you along a couple of links to the National Floor Covering Association, where the white paper is stored. It's free to download. It's one of the documents that don't have on a paywall, because it's kind of like Volvo's seatbelt. Why patent something that's going to save everybody's lives?
Yeah.
And I'll also send you a link to the other coordination documents. So there's a couple of really good documents there that'll help everybody out.
Yeah, no, I appreciate that. Yeah, we'll share that with everybody and then on our newsletter as well. So that hopefully we can get this be proactive again. Seems to be a common theme on this podcast, being proactive. But
when everybody works together.
Yeah. All right, Keith, thank you. I appreciate it.
Thanks, Seth.
And that concludes another episode of the Concrete Logic Podcast. I hope you got some value out of that episode and learned a thing or two. If you did, visit our website, concretelogicpodcast.com. Click on the Show Support tab and learn how you could be listed as a producer of an episode. Again, that's concretelogicpodcast.com. Click on Show Support tab to learn how you can support the show. And as always, Mike Dunton will take us out.
That alarm always sings couple hours before the sun comes up. Open up the side, put some diesel in the lights and wait till the trucks roll up. Yeah, this ain't how most folks live their lives, dripping in sweat, working overtime. But while they're tying their ties for their 9 to 5s, we're out here changing these skylines with hope.